In section 12.4, we are going to be discussing some problems related to the inscribed angles and just general problems related to tangents as well. The first problem that we're going to talk about is related to this idea of a cyclic quadrilateral, and this is when a circle can be drawn so that it passes through all four vertices of the quadrilateral. Okay, so then another note that we're not going to show in this problem but is relevant to cyclic quadrilaterals is that the opposite angles sum to 180. So the first problem that we're going to work through is we want to prove that a cyclic rhombus must be a square. So what I'm going to do is I'm going to begin with a rhombus. Okay, and I think I actually have a nice tool that'll let me make one. So okay, we're going to call that a rhombus. It's roughly a rhombus. And so, again, I have to start with what I know, so I know that it's a rhombus. And if it's cyclic, remember that I can make a circle that goes through all of its vertices. And so this diagram isn't going to work too well. So let me actually just make a circle. And then make a rhombus from there. Okay, and again, my drawing, this is hand drawing, so it's not going to be to scale or precise. Okay, even though I drew it like a square, I don't yet know that the angles are 90 degrees. That's what we're going to show. But I'm going to call this point A, where it intersects the circle, point B, C down here, and D in this corner. And since it's a rhombus, I know that all of its side lengths are the same. Okay, similarly, I can also say that, well, if this is a circle O, then each of these are radii, so these are going to be equal in length. Again, forgive my drawing. It is not to scale, and so these are all of equal length. Okay, and so from here, this is just going to be kind of an outline, but the idea is you use side, side, side. You use side, side, side to get congruent triangles. So side, 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 or you can use side, angle, side with vertical angles as well. Side, side, side for congruent triangles. Okay, and we also know that these are all isosceles, right? So all these would have the same measure. So base angles all measure, let's see, I'll call it x by CPCTC. Okay, so then if I add up all those base angles, I'll have 8x is equal to 360, and then therefore x is equal to 45. So what that really gives me is that I get right angles at each of these points. Okay, so I get right angles at A, B, C, and D. And then this is the last condition that I need. So that implies ABCD is a square. Okay, and again, even though it looked like a square from the beginning, I didn't want to make that assumption and I needed to show it. Okay, problem 2. So median XM of triangle XYZ has length 9. There is a typo in this slide. I want the area not of ABC because I didn't tell you what ABC was, but rather XYZ. Okay, so I'm given all this information and I'm supposed to determine the area. Okay, and so again I'm going to start with a hand drawing here, as you will on your homework. So I make triangle, let's see, this is going to be my triangle, and so x is going to be this angle and y and z. So it says median XM of triangle XYZ. So median means that, okay, here's the midpoint of the side, so that splits that into, this is going to be length 9. Given that YZ is 18, so if this entire thing is 18, then each part of these is 9. Okay, and then XY is 10. Okay, and now there's a hint here. So can you draw a circle? Well, when I look at this, I see that, okay, from this midpoint, that the distance from midpoint, and this was called M, the distance from the midpoint to the vertex X was the same as the distance from the midpoint to the vertex Z, and the distance from the midpoint M was the same as all those distances as it was to Y. So in other words, what I'm saying is that I can actually draw a circle, and we'll see how good I drew this. Not too bad. So I can make a circle here, and so this idea, this point, was a circumcenter. And when we had a circumcenter where there was a diameter, this ended up being a right angle. So I actually have a right angle, and I know two of the sides. And so the area of x, y, z can be written as 1/2 times, well, whatever the base is, so xy, or xz, and that doesn't need brackets, times yx. And I know yx to be 10, so my job is to determine what the length of xz is. So off to the side here, I can use the Pythagorean Theorem, so xz is going to equal the square root of 18 squared minus 10 squared, or this is going to be the square root of 224. And you can simplify it if you want. I didn't. Square root of 224, and so then this ends up being 5 square root of 224. And again, feel free to simplify it. Okay, so again, the idea with this is look at the information that you're given, draw a sketch, and then try and incorporate all the past information that we've done. Note, the other note that I have here is that in your homework there is a problem where you have to generalize this idea. Alright, problem 3. The last and most interesting problem of this video, and it is fun. So we have 5 circles as shown in the diagram. They're congruent, and ABCD is a square with side length 4. So I know that the distance here is 4. Okay, the 4 outer circles are each tangent to the middle circle and to the square on 2 sides as shown. Find the radius of each of the circles. So all the circles are congruent, so they all have the same radius. Okay, so what I'm going to do is I'm going to look at this middle circle. Okay, and my idea is I want to try and use the circles as best as I can to determine their relationship to this quantity of 4. So what I notice is that if I take a line, or extend the radius of the circle to this edge to where it's tangent to this upper right circle, and keep extending that radius into the middle of this upper right circle, this distance is r, this distance is r. Okay, if I do the same thing on the other, to the upper left one, and again, this is a hand drawing, so please forgive the non-straight lines, I see that that distance is also r. And if I connect those, I end up with an isosceles triangle, again, where these two sides are congruent. And actually, I have a little bit more. It is also enough for me to say that these two actually intersect at a right angle. Why? Because I know that the tangents, or that the radius meets the tangent at a 90-degree angle, but also that these radii actually lie along the diagonal from B to D and A to C. And remember that in a square, the diagonals meet at a right angle. Okay, so this ends up being a 45, 45, 90 triangle, since this is a 90-degree angle, and then the base angles are congruent. So that means that this hypotenuse length is a distance or a length of 2r square root of 2. Okay, but I'm not yet done. So that's not, I can't quite say that that is equal to this 4, but I do have enough information to say, okay, well, this is the distance of r. Again, all the circles have the same radius. So at the end of the day, what I get is the equation 2r is equal to, 2r plus 2r square root 2 is equal to 4. And so then factoring and dividing by 2, I get r times quantity 1 plus square root of 2 is equal to 2. Divide here, and so I get r is equal to 2 over 1 plus square root 2, and skipping the rationalization and simplification, you end up with 2 square root of 2 minus 2, which is approximately 0.828. Okay, so again, the idea here was to utilize your knowledge of squares, of circles, and try and come up with an equation that relates what you want to what you know.